Now we are doing the topical past papers of the Mensuration, the part which is related to the circle. Question 202412, May June 16, question number 24. Now, what is the question? The diagram shows a sector of a circle. How do you know it's a sector? Because it's a degree. A degree might be any angle. Okay. But it's not the 90 degree, it's not 180 degree. If the angle is 90 degree, it's a quarter circle. If the angle is 180 degree, it's a semicircle. But if the angle is other than 90 or 180, it's a part of the circle. We call it the sector of circle. And the radius of that particular circle is given to you 3r centimeter. So basically, we don't know the value, exact value of angle, and we do not know the value of the radius. We just have the unknown variable. If you practice this difficult question, you will easily attempt the easiest question from the other part also. A degree and a circle with radius r centimeter. And you have another circle with radius r centimeter. So basically, we are given a complete circle with radius r centimeter and a sector of a circle with radius 3r centimeter. Now, what is the question? We need to find the value of A. A basically representing the angle of the sector of circles at the center of circle. This is the center of circle. How can we find it? The condition is given to you. Condition is given in your question. What is the condition? The ratio. Ratio of the area of sector to the area of the circle. So we should know ratio means there must be a value in the fraction. So fraction means we just write this. There must be a numerator and there must be a denominator. So whatever the thing given first, the first is area of sector. We just write area of the sector in the numerator. To the area of the circle, it means it must be in the denominator. Area of the circle with radius r is representing is equal to 8:1 means 8/1. Is that okay? How I transform the given condition into mathematical equation? Is that okay? Now, area of the sector, we know for the area of the sector, we have the formula x degree over 360 degree. And here we have a degree. So we just write a degree over 360 degree multiplied by pi r square. R is the radius of the circle. And here we have the radius of the circle 3r. So we must make 3r whole square. Or you may write 9r square directly. 9
Please scroll up. Scroll down a little bit. Scroll up. Scroll up. Bus. Okay, thank you.
Is that okay till there? Any problem?
Yes. No problem.
Okay. Basically, these type of questions in which the values are not given. Only the solution comes from the unknown variables. These are called the difficult type questions, and you must practice these type of questions. If you are okay with these questions, then the questions in which the values are given, it will be easy to handle those questions. Now, is that okay? Why I write 9r square here? Is that okay? I write a degree over 360 degree multiplied by pi r square. The formula tells us r square, whatever the radius of the circle is given, make a square on it. So the radius given is 3r. So if we square it, it becomes 9r square. Is that okay? Now, for the area of the circle means they are talking about this. It is also mentioned here. Area of the circle with radius r. It means another. So for the area of the circle, we just write pi r square. Why I just write r square? Because the radius of this circle is simply r. It means this r and this r has some relation. They are the commons. So we can cancel them easily. So it's equal to 8/1. So we can simply cancel out pi with pi, r square with r square. Is that okay? Any problem? And you may cancel out this also. 9 is the 9, 9 for the 36, and 0. We should know the little bit calculation also, because in paper 1, 4024, calculator is not allowed. If you are doing that Excel, calculator is allowed in IGCSE in paper 2, and in 4024 paper 2, calculator is allowed. And but there is a change in paper 1 in 4024, in which a difficult type of question comes since 1 2 years. So you need to practice little bit, and you know the multiples and you know the tables without calculator. So now a degree is equal to what left, only 8 here, and there is nothing except 40. Just multiply it with 40. So a equals to 80, 8 fours are 32, and you must need to write this degree. Make sure you must need to write the unit of any value which is you are whatever you are writing in the answer line. Is that okay? 320 degree. Use that one. Is there any problem? Should we move to the next part?
No problem, no problem.
Now, we move to the next part. In next part, what we need to do, find an expression. Expression means we just need to write a value in terms of pi and r. In terms of pi and r means we do not get exactly a number. We might get a number with the value pi and r. Okay. For the perimeter of the sector, perimeter of the sector means they are talking about this figure. For the perimeter, what we must know? This boundary, and we know it's 3r. This boundary, we know it's also 3r because it's also the radius. And another thing which we should know is this line. What we call this line, the arc length. We just represent normally arc length with S, we can say. So basically, for the perimeter, we just need to find S, the arc length, and we know 3r plus 3r. So it's the perimeter of that given sector. But what's the problem? They said find an expression in terms of pi and r. They only need the value in pi and r, not in any other variable. So what I write here, S basically representing the perimeter, the arc length of that particular sector. And we know the formula for the arc length, it's x degree. So we just write a degree over 360 degree multiplied by 2 pi r. And 3r plus 3r becomes 6r. Or we can do it directly. In place of a degree, we may write, because we know the value is 320. So just write 320 here. Please save your time. Now cancel out the calculations. Let's say 0 is 0. And you can say if we just cancel out 2 1s are 2, 1 0, 2 8 is 16. So it's 32 over 18. And you will reduce it with any other variable. So it's 6r. And this pi r is also here. And if it is reducible, the fraction, you may also reduce it. Okay, it's reducible. Just write 2 9s are 18. 2 1s are 2, 2 6 are 12. So it's 16 over 9 pi r plus 6r. If you want, you may do a next step also, taking the LCM. It becomes 9, 16 plus pi r plus 6 9 are 54 r. You may do another step, just take r common from here. You may write r over 9, 16 pi plus 54. You may take another common numerator, because 16 and 54 are the even numbers, would also come in the you can say in 2. Or you may stop at this position. Is that okay? Any problem?